Hello students, in this video my name is Sushant Garg. In this video we are going to solve another question of heat transfer which has been asked in JEE Advance 2018 examination. Okay, so here we have been given two conducting cylinders of equal length. Lengths are equal but radii are different. Two heat baths kept at temperatures T1 and T2. Here temperature is 300, here temperature is 100. The radius of the bigger cylinder is twice. Its radius is 2r and the smaller one is r. And the thermal conductivities of the smaller and larger are K1 and K2 given. If the temperature at the junction temperature is 200 Kelvin, so we have to give the ratio of conductivities. So let us do it. First of all, if its cross section area is A1, so it will be equal to pi r square. Its cross section area is A2, which will be equal to pi 2r ka whole square 4 pi r square. So let us say if its area is A, its area will be 4a. Okay, so if the heat is going from this K1 to K2 like this rate of heat flow, the temperature encountered is T1 here, T2 is here, so 300 is here and 100 is here. So the heat flow will be calculated on the basis of temperature difference upon thermal resistance offered by the material. Here K1 will offer the thermal resistance R1 and K2 will offer the thermal resistance R2. So they are in series, so to get the equivalent thermal resistance we have to do R1 plus R2 because they are in series. Current is flowing first in K1 conductivity material, then in K2 conductivity material. All the heat is going to both. So this length is L, its area we have calculated A, conductivity K1, so R1 will be L by K1A and R2 area is 4A, length is also L, so plus L 4A K2 we can write. So this is the thermal resistance. So the rate of heat flow from K1 to K2 material is, the heat temperature difference is 300 minus 100 upon this RTH. RTH value is L by K1A plus 4 L by 4A K2. 300 minus 100 is 200. Then we can take common L and A. So here we get 1 by K1 plus 1 by 4 K2. Okay. So in the next portion what we do, we just have to take this material. In the next portion, if we take K1 only, the same heat is going through this to this point. Here temperature is T1 and the junction temperature is given as 200. The junction temperature here is, let us say T, 200 Kelvin. Here it is given as 300 and this length is L, area is A. So thermal conductivity of this portion R1 will be L by K1A and the heat which is flowing through this area is its temperature difference T1 minus T upon its thermal conductivity. So 300 minus 200 upon L by K1A, we can write it as 100 by L by K1A. So this is the heat flow which is we are getting through K1 only, and the same heat is flowing through the whole material from K1 to K2. We have calculated this. So we have to equate both these equations to get our answer. So first equation is this, Q equal to 200 by L by A 1 by K1 plus 1 by K1 plus 1 by 4 K2 equal to 100 by L by K1A. So this is the second. We have equated first to second. So 100 में 200, this 0 0 will cancel, L by A will get cancelled. We will left only by 1 by K1 plus 1 by 4 K2. Here 2 is also present. So 2. Here we have 1 by K1. So we can write it as 2 into 1 by K1. Just 1 by K1. So 1 by, this will get cross multiplied to 2, and this 1 by K1 plus this will become, this whole will get cross multiplied to this, so 1 by K1 plus 1 by 4 K2. So this will give us 2 by K1 is equal to 1 by K1 plus 1 by 4 K2. So 2 by K1 minus 1 by K1 is equal to 1 by 4 K2. This is 1 by K1 is equal to 1 by 4 K2. So this will give us the ratio K1 by K2 is equal to 4. So this is our answer. So this is the solution of this question. In the next video, we are going to take another question of heat transfer related to Newton's law of cooling, which is asked in previous year JEE examination. Till then, goodbye, study hard. We'll post the next video as soon as possible.